Hello everyone and welcome back. So with this session we will talk about high-speed logging. In the previous session we talked about remote logging. We have seen how to configure the big IP to send the logs to remote syslog servers. But the problem with the legacy remote logging is the big IP will send all log messages to the same server. So if you have LTM and ASM, the WAF app enabled on the big IP, and you configure the legacy remote logging, the logs for the ASM, the logs for the LTM, even if you enable the firewall, the AFM, then the AFM logs as well will go to the same server. And this is something you may not want. You may have a scenario where you want to send the LTM logs to syslog server 1, the ASM logs to syslog server 2, and the AFM logs to syslog server 3. Different teams because the web application firewall team is separate from the data center firewall team is separate from the application load balancing team. So, and each team has their own syslog server to look at and to troubleshoot their own log messages. So if you have a case where you want to send certain type of logs to certain destination, maybe you want to format the logs with SIM format like Splunk, like ArcSight. That's also where you need to use high-speed logging. In general, F5 they don't recommend the use of remote logging legacy, the simple remote logging. They always recommend to use the high-speed logging methodology. Now, to configure and use the high-speed logging, we have multiple components that we need to configure. First of all, high-speed logging, it uses the concept of pool. You define a syslog server's pool. Even if you don't have multiple syslog servers, even if you have single syslog server, you have to use pool. You have to create pool, create node, and make this node member of the pool. Now, the great advantage of the using the pool as a destination for logging is we're gonna see how we can use the load balancing algorithms on the pool. If we have multiple syslog servers, you will use monitor on the pool as well, so you can use a monitor to continuously check on the availability of the syslog servers. So if a syslog server is down, you stop sending logs to that syslog server. And if you have pool of 3 servers, you will also have the option to replicate the logs. So the same copy of the log, it can go to server 1, it can go to server 2 and 3. So you have 3 servers, your log messages will be copied on log server 1, 2 and 3. So you have multiple copies of the log message if you want this scenario. Now, after you create the pool, you have to create an HSL destination. An HSL destination is nothing but you are telling the HSL that the destination of the log will be this pool that I have created. And then you have to create publisher. So the destination, when you create a destination, you just choose the type of the destination, remote high-speed log, and you select the pool that you created. And you select the type of the syslog servers, TCP or UDP. And then you select the distribution method. If you have created the pool, the syslog server pool, with multiple servers, you select the distribution method. Do you want the logs to be sent to both servers, server 1 and server 2? So replicated, so the same copy of the log to be sent to server 1, same copy of the log to send to server 2. Or you want balanced. Balanced means use the pool load balancing algorithm. The load balancing algorithm of the pool, for example, by default, it's round robin. So when Big IB sends log to this destination, to this pool, he will send 5 log messages to server 1, 5 log messages to server 2, for example. Or you want to use adaptive. Adaptive means the Big IB will send to the first server until the server is overloaded with lots of log messages. Then the Big IB will start using the second server. So it's kind of we use the first server until the capacity of the first server, like the bandwidth, mainly the bandwidth, the amount of logs we are sending to the first server is high. Then we start using the second server. So after you define the HSL destination, then we need to create the log publisher. The log publisher is just a container that says this is our destination. It's actually the publisher is a link between the filter and the destination. It is the link between the filter and the destination. You create the pool, you place two syslog servers in the pool. You create a destination, you say, this is an HSL destination that uses this pool, pool 1. Now, to start sending the logs to pool 1 or to this destination, we need a filter. What is filter? Filter says send the logs of LTM, for example, uh, to this publisher. And then the publisher says the HSL destination is this, and then the HSL destination will say this is the pool. Uh, let's have a look at it in the configuration and let's see how it works. So, first of all, as we said, we need to create the pool. So before creating the pool, I will create node. These are our application node. I will create a node for syslog. So node syslog1, the IP address 10.00.51. Click finish. Node syslog2. We have two syslog servers, 10.00.52. So now we have two syslog servers. Let's go and create pool. Pool syslog. Monitor. We don't have by default a monitor for the syslog servers, but we can use the UDP monitor because our syslog is UDP based. I will come back to explain the monitor, how it works with the UDP, because you will be thinking if this is a UDP based traffic, UDP, when you send the traffic to a UDP server, the server will not give you any response or any feedback because it's UDP, it's one way. But there is a mechanism that Big IB is using to monitor the UDP servers, and in our example, syslog servers. So we'll come back to this, but let's first use it. Node list, our UDP server, syslog server, sorry, port 514, the syslog port, and our second node. Click finish. Let's see if the pool will go green in a few seconds. Yes, so the pool is green, which means we have two syslog servers that are up and running, listening on port 514. So we have created the pool. Now we need to create HSL destination. We go to logs, configuration, log destination. By default, the log destinations are the local, which is the on-device logging. Let's create HSL destination. The type, as you know, it should be high speed logging. The pool, we have to select the pool that we just created with 2 servers. TCP, no, our current syslog servers are UDP. Distribution, I won't replicate it. I want to see the same log message sent from big IB to both syslog servers. We will test replicated now, and then we will come back and test balanced. Click finished. Now we have a high-speed logging destination. What is next? Publisher. Publisher is nothing but a link between filter and destination. So create publisher, select the destination that we just created, click finish, and then the last one is the filter. Once you create the log filter, the big IB will start sending log messages to the syslog servers that we defined in the pool. So let's create the log filter, filter 1 HSL. Now what is the logging level? Of course, we will not do debug because, as we said, debug will send a lot of log messages. This is only we use when dealing with F5 support team. Let's pick informational. Source. What is the source of the logging? This is where you define if you want the LTM logs to go to the publisher 1, and then you select the MCP. These are the processes, the daemons in the big IB, and there is a document from from F5 talk about each one of them. For us, the big IB one, the LTM, is the MCP. Now, even if you click on the help here, you will get a fair documentation talking about each one. So for us, the log, when we disable pool, enable, disable node, disable pool member, disable virtual server, these type of things, the source will be MCP daemon. So we're gonna test now the MCP daemon as a source, send it to our HSL publisher, the one that we just created. And remember that the HSL publisher that we just created is linked with the destination. And the destination that we just created is linked with the pool that we created. So now all the log messages related to the LTM, pool, nodes, all these objects will go to this publisher, which means it will go to the destination that we define, it will go to the pool that we defined. Let's check on the syslog server and see if it's receiving traffic. If it's receiving logs. So if you keep an eye on this, you will see that every 5 seconds, the syslog server is receiving a message from the big IB default send string. This is actually the monitor. This is actually the monitor, the health monitor that the big IB is sending to the syslog. So this is the UDP health monitor that we have used. So we try to put both. You can see both they are receiving health monitor. Now let's try to motivate some log messages. Let me go to the node list. Let me disable one node. Yes, you see the log message showed on both. The same log message disabling the node showed up on both syslog servers. So the same log message showed up on both. Why? Because when we created the destination, the HSL destination, we selected replicated. Let's select balanced. Balanced mean what? Means we will use the pool load balancing algorithm, and our syslog pool by default it's configured with round robin. This means the log messages they will go half to the server 1, half to the server 2. So you will not see the same log message on both devices. No, it's no longer replication, it's balanced. Now to generate a lot of log messages to test this, let me go to the filter and let me choose debug. Once you choose debug, there will be a lot of log messages. Click update, go back, you see the log messages now one time here, one time here, one time here, one time here. It's kind of a load balancing. Now let's go back and reduce the severity to informational. We don't want to overload the syslog servers with a lot of messages. We keep it on the informational level for the MCP. Quickly, so what we have done so far, we created a pool with 2 syslog servers. We selected UDP monitor, and then we created log destination. This log destination pointing to the pool, selecting the UDP or TCP as a protocol for logging. Distribution method, let's keep it replicated so that both servers they receive copy of the log message. After we created the destination, we created publisher that is pointing to this destination. And then finally we created the filter that will define which process on the big IP you want to send the log messages of which process and to which publisher. What I'm going to do now is I'm gonna go back to the pool. I will split the syslog pool to 2 pools and use one server in each pool so that we can test sending the LTM logs to one server and we can test sending the packet filter logs to another server. So let me create pool syslog 2, take a UDP, take server 2, click finish. Let me remove this server from the first pool. So now we have 2 pools and one server in each pool. Let's go back to the logs destination. Now we have the first destination pointing to the first pool. Now we're going to create another destination, HSL destination 2 This is for packet filter. We will use it. And type is high-speed logging. The pool, the second pool, it's UDP. Now distribution doesn't matter really because now we have single server per pool. Click finish, and then we go to publisher, create another publisher, HSL publisher, and the second destination. Let's just, this is for packet filter, the logs related to the packet filter, because usually packet filter logs are related to who can access and who cannot access, and people trying to access while they cannot access. So these type of logs usually sent to SIM server or to the SOC team to identify who is trying to access something that is denied from access. So we have the HSL publisher. Let's create the filter. We create the filter, HSL filter packet filter informational. Now we need to select the process packet filter as a source. Log publisher, the log publisher that we just created. Click finish. Now we have two filter for the MCP process, a filter for the packet filter process. Let's see what we are receiving on the log servers. So server 1 is still receiving the MCP logs. So if I go to the pool, select the web application pool, let's disable one member, for example. This will come on the log server 1. Why? Because log server 1 is part of the pool that is used by the filter MCP process. Now, server 2 will only receive log messages related to the packet filter. As of now, we did not configure the packet filter. Let's create a test packet filter. Let's add a rule. First, we need to enable, remember it's disabled by default. So, enabled. Let's create a rule, just any. Accept on the external interface, protocol TCP, source host any, destination, we're gonna select the virtual server, and destination port 80. We will enable logging so that we receive the log messages. So click finish. Sort order first, doesn't matter. This is the only one we have. So we have just a testing packet filter. It's not blocking anything. It's allowing, and it's logging as well. So I expect the packet filter match when we generate traffic that match the packet filter to receive a log message here. Let's test. Let me open the testing client machine. Control F5. Yep, we have the web application working. Let's see statistics on the packet filter. We have 18 matches. Let's see the logging. On server 2, you see, now we can see the log messages. Now if check this is the server 1 logging. So you see the packet filter logs now coming to server 2, not coming to server 1, while the configuration changes, disabling object, enabling object is coming to server 1, log server 1, it is not coming to log server 2. This is how you distribute different type of logs to different syslog servers by defining pool for each destination. We have pool 1, pool 2, and then under logs you create 2 log destination, you link each one to separate pool, and then you create 2 publishers, link each publisher to separate destination that we created, and finally the filter. And the filter is important because this is where you differentiate the source. So all the logs related to the packet filter process goes to this publisher, while the logs related to the MCP process goes to this publisher.